Thank you, Bernd. Hello and welcome everybody to our webinar on VACUU technology, features and applications, which Konstantin and I will be given. What can you expect today? First, I'd like to say some words on requirements and trends in modern laboratory, which led to the development of VACUU. In the second part, we would like to give you once again an overview on the new vacuum pump VACUU, which we introduced in September last year. It's our new oil-free and chemical-resistant vacuum pump for the fine vacuum range down to 10⁻³ millibar. Those who have already visited our introductory webinars might recognize the one or the other, but still I think we have some interesting news for you to offer. Afterwards, we will explain the functional principle and talk about the most important features and specifications of VACUU. And last but not least, the applications in practice will get some important portion of this talk, because this is, I think, also something which is interesting for you as well. So what are the requirements in modern labs at the moment? Especially more and more value is placed on the purity of processes. Contaminations have to be avoided as far as possible. In addition, topics such as efficiency and reliability of the applied technologies are coming more and more to the fore. And last but not least, sustainability is a very important selection criterion for equipment in the modern lab. What does this mean translated to vacuum technology? First of all, we can see an increasing use of oil-free, dry technologies, where the absence of oil and other utilities is very important for the customers. In any cases where aggressive gases and vapors have to be pumped, the chemical resistance of the vacuum pump is a basic requirement for reliability on longevity. In addition to the absence of oil, in many cases the absence of particles generated through abrasion is also a very important selection criterion. A very decisive requirement is especially a low effort for maintenance and service, so minimal service demands which lead to continuous operation without any concerns of the customers is also very important. For pressures down to 1 millibar, diaphragm pumps meet all these criteria and have proven themselves and established over the last decades. In the pressure range down to 10⁻³ millibar, there is so far no technology which combines all these requirements at the same time, and VACUU now fills this gap. What is this pump all about? In the following, I'm going to show you the working principle and talk about the most important specifications and features. VACUU comes in two versions, VACUU 10 and VACUU 10C. Both versions have an ultimate vacuum in the 10⁻³ millibar range, and both versions are 100% oil-free. VACUU is the ideal solution for processes where aggressive gases and vapors have to be pumped due to its high chemical resistance. VACUU 10 is the alternative for clean processes where no corrosive gases have to be pumped, for example in physics or analytical applications. Both versions have in common that they don't generate any abrasion and don't have wear parts. VACUU is based on screw pump technology which has been perfected for laboratory applications. The working principle consists of two intermeshing spindles with counter-rotating threads which rotate in opposite directions in a stator, which can be seen good at the moment. This counter-rotation in the stator housing advances the enclosed gas volumes from the inlet to the outlet, and it's expelled chamber by chamber. The ultimate pressure of such a pump is determined, since it's a screw pump, it's a gap-sealed pump, it's determined by the gaps between the rotors and the stator and between the rotors themselves. In addition, the spindle geometry and the high rotational speed are important factors for the ultimate vacuum, as well as the pumping speed. For VACUU, the rotational speed is 12,500 RPM. The special design of VACUU encloses cantilevered spindles, which means they are only fixed on one side, and a magnetic gear that synchronizes the two spindles with each other. That leads to the fact that the pumping chamber can be kept completely oil-free. For this, you can work with an ultra-clean processes and accordingly generate clean products. No consumables are necessary. By eliminating oil changes and the disposal of waste oil, which might be contaminated with chemicals, it also leads to low operating costs and is a very sustainable technology. To meet the requirements in the lab, especially in the chemical lab, a high chemical resistance of the technology is necessary. With VACUU, all materials in the flow path are manufactured from chemical-resistant polymers. A thick yet precise peak encapsulation protects the spindles and the stator housing from chemical attack. Other technologies, which also work in this vacuum range, don't offer this high chemical resistance. This makes VACUU uniquely capable of handling aggressive gases and vapors. You might know from the use of rotary rain pumps, you have to protect the pumps by cold traps in a lot of cases. This is not necessary anymore with VACUU in most cases. VACUU also comes with a very high vapor and condensate compatibility, and it has an integrated regeneration mode, which enables you to quickly dry the pump after processes with high vapor load and make it ready for use directly after the last process. And as customers told us up to now, they really like this feature. The unique design with no wear parts, that means no touching spindles, gives you also more advantages. The non-contact design equals with the design without wear parts. All components are manufactured with VACUU brand quality down to the smallest details. This is a lasting promise. So with VACUU, you don't have scheduled maintenance. Regular maintenance is no longer necessary. This enables you to operate your processes continuously without interruption. In general, you have reduced operating costs, again due to the missing of oil and other consumables, and no scheduled maintenance, and can use the pump for a long time with hassle-free operation. By now, at the latest, it should be clear the slogan of VACUU is not just a fancy-sounding invention of our marketing department, but it captures the essence of the pump. VACUU is pure vacuum, nothing else. In the following, I'd like to give you an overview on the most important features and specifications. Both versions have an ultimate pressure of 5 times 10 to the minus 3 millibar. The pumping speed of the version VACUU 10C for applications where aggressive gases and vapors are pumped is 9 cubic meters per hour. VACUU 10C, the alternative for processes where non-corrosive gases are pumped, is 10 cubic meters per hour. VACUU 10C offers a very high chemical resistance and can be used for processes with high aggressive gases and vapors. Especially on this pump, I'd like to notice that there are no limitations for the applied vacuum or working range. You can use VACUU over the complete pressure range from atmospheric pressure down to 10 to the minus 3 millibar without any restrictions. In the case of other technologies, there is often a restriction that, for example, pressures above 200 millibars are not allowed for a longer period of time. This makes VACUU not only interesting for the fine vacuum range down to 5 times 10 to the minus 3 millibar, but also especially interesting for the transition range between rough and fine vacuum, let's say from 10 millibar down to 0.1 millibar. where diaphragm pumps are reaching their limits. For easy system, I forgot the regeneration mode. VACUU, as I already said, is equipped with an integrated regeneration mode, which allows for quick drying cycles after high condensate load. So the pump is very quickly ready to use. For easy system integration and remote control via process control systems, VACUU is equipped with a modern Modbus RTU interface. On the next slide, there are some pumping speeds, typical pumping speeds curves shown for VACUU 10C in blue and VACUU 10 in gray. The shape of the curve is quite typical for screw pumps. It starts at high pumping speed at atmospheric pressure, then there is a dip at around 300 millibar, and the pressure, the pumping speed increases again with shrinking pressure, with lower pressures, and reaches its maximum again at 10 millibar around, and has very high pumping speed down, far down into the fine vacuum range. So as I said already, it's very important that VACUU can be used continuously over the complete pressure range. There is no restriction, even if there is a little dip in the pumping speed at higher pressures. It doesn't do any harm to the pump, and it can be also used, for example, to pump down larger vessels with one and the same technology, with which you also work at the ultimate pressure at the end. So this was the short overview of the functional principle and the essential features of VACUU. I hope I could convince you of the manifold advantages, and would like to hand over to Konstantin, who will give you an overview of the main applications and application-specific advantages. Thank you.
Thank you, Barbara, and thank you also, Bernd, for the earlier introduction. Contrary to everything you said, I'm obviously at this point just a grossly overpaid speaker. But kidding aside, I'm happy to be here today to now talk a little bit to you about applications where VACUU really can shine given its unique set of features. Barbara has taken you through a very quick tour of the technology, of the features that make this a unique pump. What I want to now do with you is show you how these features translate into benefits of your applications that will make these more efficient, better, and just take them to the next level as far as performance is concerned. On this slide, what I want to show here is a brief overview about possible applications where VACUU can make such a difference. What I think is obvious here is that VACUU covers a wide range, an incredibly wide range of application. Everything from drying processes to work with a Schlenk line to freeze drying and analytical work. Especially in analytics, VACUU may serve as a main pumping technology, but it may also serve as a backing pump technology for turbomolecular pumps with its whole unique set of particular benefits. But before we go deeper into some of these applications, I want to show you where VACUU, since we've started selling this late in the fall of 2020, where customers such as yourselves have gone to this technology. What you can see here is that VACUU especially is being used in classical laboratory applications in the chemistry and life science fields. At the top of the list currently is Schlenk lines, freeze drying, and vacuum drying ovens. Particularly with Schlenk lines and freeze drying, VACUU is mainly replacing oil pumps, a very established technology with a whole set of problems. Let's start with the oil. That's the first and foremost problem. Oil pumps inherently are a technology that do offer great vacuum performance. However, it's inherently not a pure technology. It's not a dry technology. And this is really where VACUU brings all kinds of new benefits to the table. But you can also see that VACUU has been successfully used by customers in various different applications. Evaporative work, such as in reactors, in various final drying scenarios, in distillation, or in mini plant setups. VACUU, in a summary, improves your application in a wide variety of such applications. But now let's go into a little bit more detail about how VACUU can improve your application. I want to start with Schlenk lines. For those of you who don't necessarily work with Schlenk lines day in and day out, for those who do, please excuse the short description here. I want to give you a brief overview. Schlenk lines are usually used to safely manipulate moisture in air-sensitive compounds and for residual drying. As I said, the main pumping technology that they're operated alongside with are rotary vane pumps. The problem you're facing here is that the involved chemistry often requires you, the user, to use a cold trap to protect your oil pump. The cold traps in turn then have to be periodically regenerated, which may prevent you from running your experiments continuously and, for example, overnight. I haven't really personally worked with Schlenk lines in my time in the lab, but I have been forced to come into the lab at 2 a.m. in order to replenish liquid nitrogen in a cold trap. From what I remember, that's not exactly fun, probably not even the safest thing to do, and just an obstacle to continuous processes. And with all the cold traps in place that you may have to protect your oil pumps, you still are faced with routine oil changes. VACUU is an oil-free technology, plus it offers superb chemical resistance, which makes cold traps a thing of the past for most processes. So VACUU really addresses challenges that you are facing today. There are no oil changes involved, and continuous safe operation, even overnight, is possible. I hope you can see that this is a great benefit to you users in the lab. Next, I want to talk a little bit about freeze drying. Admittedly, I feel a little bit silly trying to offer advice on freeze drying after Klaus Hudel's presentation, but nonetheless, I'll try. It's maybe from a different perspective. Freeze drying, as we've learned in the previous presentation, is probably the most gentle method for drying various samples, and it's commonly employed in the life sciences, pharmaceutical, and food industries. For correct process control, working pressures below 1 millibar, below usually the triple point of water, are required. And especially for any residual drying phase, a deep ultimate vacuum is indeed essential. And anywhere where pure products are being made, probably in conjunction with aggressive solvents, existing technologies do face some serious challenges. Because oil pumps might be ruled out from the start, because they will never offer you a pure product, since the risk of oil backstreaming into the application cannot completely be excluded. Some customers then resort to alternative technologies, such as scroll pumps. But scroll pumps inherently, due to the tip seal technology, generate abrasion, which, of course, is more common on the exhaust side of the pump, but again, it cannot be excluded that some of this abrasive material may backstream into the application and contaminate precious products. VACUU again offers a solution for these demanding freeze drying processes. It offers clean vacuum with high chemical resistance, and all that down there into the 10 to the minus 3 millibar range. This is what makes it so uniquely suited for your demanding freeze drying applications. And thanks to its integrated regeneration mode, VACUU may also help you out once a freeze drying process may have gone wrong. Because even after it's seen high vapor loads, it can be dried quickly using the regeneration mode, brought back to its specified ultimate vacuum, and ready for the next process. I want to now sort of move out of the regular world of laboratory scale applications and talk about settings where we are in a mini plant or pilot plant, where we're actually in production or pre-production phase. There are a lot of applications currently that are evaporative, where a premium on purity is definitely placed. For example, in food industries where flavoring agents are being made. Oil pumps are completely ruled out because of the risk of contaminations. People currently use diaphragm pumps in conjunctions with elaborately built reactive systems that are super leak tight in order to provide the reaction conditions that allows the setup to work. However, with certain solvents with very high boiling points, users may face some limitations. VACUU now opens up a whole avenue of reactions for these customers where the deep ultimate vacuum alongside with a clean, oil-free, chemical-resistant technology can offer a real benefit to you in the lab. Well, I do hope that, like Barbara has done with her technical presentation, I've been able to show you how VACUU indeed is pure vacuum and nothing else. And this is not just a slogan from a creative world of marketing, but something that does indeed capture the essence of the pump. At this point, I want to thank you for your attention. Thanks for taking part in the lab days. And I'm going to open the session up for questions that you may have.